Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. As I promised, this is the third and last part of the Regents Algebra 2 for August 2025. So let's start. Again, we have parts 3 and 4. In parts 3, we have 4 problems, and part 4 is only 1 problem. These problems are 4 credits each, but of course you have to show your work. So the first problem said that the gross domestic product, or the GDP per capita, measures worldwide economic output per person. So the GDP per capita Y in dollars X years after 1990. So these are after you add 1990 to the year, is listed in the table below. Okay, yeah, I printed in large print, so we have several pages for the problem. The first part said, based on these data, write an exponential regression equation to model the GPT. I keep saying GPT because I'm crazy. The GDP per capita in dollars X years after 1990, round all coefficients to the nearest hundredth. Okay, so we know that to write an exponential regression, it would be in the form y. So here we would say, did they? Yeah, they said x and y, so you don't need to, or since they didn't really say y, you can say let y be the GDP. I was going to write GPT. The GDP per capita X years after, well, I could have said just GDP equals, right? After 1990, so that I have to define what I am using for Y. They didn't tell me. I didn't say X because they already said X. Well, we said after 1990, but anyways. So I know that this equation equals A, B to the X. And I can use my calculator to find A and B that they ask for. So we'll get the calculator and go to stat, edit, and then we will fill the x's in the first column. So 1, 6, 18, 25, 29. Make sure that you enter the numbers correctly, because sometimes if you are working fast and maybe the 25, the 2 entered, but when you click the 5, you didn't click it properly, so it says 2. Of course, your answer would be wrong just because you were rushing. So just make sure you look at the numbers and make sure that you enter, especially in the Y, because there are several digits. You can just look at them and see 96, 80, 10, 201, 13, 7, 13, 15, 552, and 16, 9, 76. Okay, you check them. And then you exit and go to calc and click 0, or basically here is the 0 is the exponential regression. They ask you the model. The model already is stored. So you can see that it doesn't give you R and R square, but you can easily go to the catalog and make sure that these diagnostics are turned on. But here we don't care about that. They don't ask us unless maybe in the next few questions. Okay, so we say A equals 9290.57 and B equals, so that's what they want. No, they want the whole equation like this. So first we enter these in the nearest hundredth, and then we say either Y or GDP, since we already defined the Y here. So the GDP equals 9290.57, and then between parentheses, don't include everything in the parentheses, or else everything would be A to the X times B to the X. Here we only have A as a constant, and then b only is raised to the x power. Okay, so that's dollars per capita. Use the rounded equation from part A. So don't use the stored value. They tell you just use the rounded equation in part A to algebraically determine to the nearest tenth of a year the number of years after 1990, meaning X, but just to the nearest tenth, when the GDP per capita was 15,000. Okay, so we write GDP is $15,000 equals 9290.57 times 1.02 to the x, and we want to solve for the x. So of course, the first thing you do to reach the x is to divide both sides by 9290.57. This value would be stored in the calculator. I'm not going to enter all the digits, but you keep those because that's what you will use. Meaning you can write 1.6145 equals 1.02 to the x. And then to solve for x, you have to take the natural log of both sides, right? And when you take the natural log of something to the power of x, that becomes x times the natural log of 1.02. And finally, to find x, you divide both sides by natural log of 102. So x becomes natural log of 1.6145 divided by natural log of 1.02. Let's see, natural log of 1.6145 divided by natural log of 1.02. You get 24.2 because they want it to the nearest tenth. And then after 99. You have to go back and check, does it make sense? You see that at 25 years, it was 15.5. So at 24.2 to be 15,000 makes sense. But if I get the answer as, for example, 15, I'd say, oh, 15 has to be between 10 and 13. No, it's not. If I get 30 something, oh, it has to be higher than $17,000. So just a quick check to see, because I might have clicked on the wrong button or one of the buttons were missed, and so on and so forth. So that's the first question out of the 4. When we move to the second one, it tells you, consider the function f of x, it's a cubic function below. Is x plus 3 a factor of f of x? Justify your answer. I have really 2 or maybe 3 ways to do it. I can use long division. I can use synthetic division, or I simply can substitute -3. So really any of those would be correct. Meaning, if I say f of -3 and see if I get 0, because if I get 0, it means, yes, it is a factor. I will get -3 cubed plus 3 times -3 squared minus 2 times -3 minus 6. The first one is -27. The second one, -3 squared, is positive 9 times 3 is 27. So these two would cancel. Negative times negative is positive, and 2 times 3 is 6 minus 6. Of course, it equals 0. Okay, I can do the easy one would be a synthetic division. If x plus 3 equals 0, then x equals -3. That's the root. I have 1, 2, I'm sorry, 1, 3, -2, -6. The 1 drops down. 1 times -3 is -3. They add up to 0. That's why the first two give you 0, right? 0 times -3 is 0, plus -2 is -2, and -2 times -3 is positive 6. They add up to 0. So yes, it is. So you say, yes, x plus 3 is a factor of f of x. You can say since f of negative 3 equals 0, or you can say because dividing, you don't have to say synthetic or long division, dividing by x plus 3 gives 0 as a remainder, or gave a remainder of 0. Something to that sort, one of these or something similar, okay? So that's the second. No, there is another part to it. B, determine all zeros of f of x. The synthetic division would have been easier because when you do that, you get the next equation. This was a cubic equation, so that would be a quadratic equation. X squared minus 2, because there is no x, minus 2 equals 0, right? These are a very simple problems so far. So you add 2, you get x squared equals 2. You take the square root of both sides, and you make sure you take plus or minus. I've seen students say x squared equals 2, so x is root 2. No, it's plus or minus. Square meaning you have two answers, okay? So x equals plus or minus square root of 2. So now you can say all the zeros. We already determined negative 3 or negative 3 to be one of the roots. Root 2 is another, and negative root 2 is a third. And that's all. You don't need to do much work. This one is also very simple. We move to the third problem. The third problem, oh, you have to solve algebraically 3 equations and 3 unknowns. Oh my God, this is too much. No, usually they give you something that you can use to eliminate quickly. So I'm going to call, I will number the equations. That's just for simplicity to myself and even to the grader. I'm going to say, okay, I have 3 variables. I need to decide which one I can get rid of in the 3 equations, 2 at a time, and that would reduce the system into 2 by 2, and then either substitute or do elimination again to find one of them and then go back and substitute. Okay, so I can see negative c and positive c, or b and b, so I can get rid of the b or the c easily. The way I'm going to do it to myself is to, for example, I want to get rid of the c, since one is already positive and the other is negative. I'm going to say equation 1 plus equation 2. So I'm telling myself and the grader what I'm doing, where the numbers that will show up here, or where the equation came from. I'm adding these 2 equations. So 2a plus 4a is 6a. b plus b is 2b. Negative c and positive c is not 2b. Oh, no, I'm sorry. Not 2b or not 2b. I'm sorry. They cancel each other. And negative 4 plus 3 is negative 1. So here is the equation, the first equation. I got rid of the c. Now I have 2c in the third equation. So either I multiply the second by negative 2 and add it, or multiply the first by positive 2 and add it, right? Because I will get negative 2c and positive 2c. So that's what I'm going to decide. I'm going to say multiply equation 1 by 2, and then add equation 3. See, it's so easy for me to check my answer later. If I get something wrong, when I check, I can go back and find it easily. Multiply this by 2, I get 4a. Add 3, which is minus 2a, is 2a. Multiply this by 2 is 2b. Minus 3b is negative b. Multiply this by 2 is negative 8, plus 11 is positive 3. Okay? And then I'm going to call this equation 4, and that's equation 5. Now, do you see that I have 2b and negative b? So if I multiply 5 by 2 and add it to 4, so 4 plus 2 times 5 4 is 6a. 2 times 2a is 4a. 6a plus 4a is 10a. Then 2b minus 2b is 0 equals negative 1 plus 2 times 3. Negative 1 plus 6 is positive 5. I'm going to divide both sides by 10 to get a equals 5/10 or 1/2. Now, since I have a, I can substitute in one of these two equations to find b, right? So I'm going to say substituting in, say, 1, I get 6 times 1/2 plus 2b equals negative 1. 3 plus 2b equals negative 1. Subtracting 3 from both sides will give me 2b equals negative 4. Dividing both sides by 2, I get b equals negative 2. And finally, now I have both a and b. I can substitute in 1, 2, or 3 to find c. Let's say we substitute in 1. Oh, I'm sorry. Here I said substituting in 1. That should be substituting in 4. It's the first equation, so I wrote 1, but I'm substituting in this equation. And here I substitute for 1 or 2. Let's do it in 2. It doesn't really matter. You can substitute in 1, 2, or 3. In 2, I have 4 times a plus b, but b is negative 2, plus c equals 3. 4 times 1/2 is 2, plus negative 2 is negative 2, plus c equals 3. That's so easy because 2 minus 2 cancel, and you get c equals 3. You have to check, just because I might have done some math error because I'm in a hurry. I already substituted in 2, so let's substitute in 1. 2 times 1/2 plus b, which is negative 2, minus 3, which is c, equals. This is 1 minus 2 is negative 1, minus 3 is negative 4, and this is negative 4, correct? You can do it also for the third, but if it works for 2, then definitely it's going to work for the third. And that is the third problem. See, we finished in less than 20 minutes. So that should be okay. Now, when we move to the next problem, it gives you f of x and g of x, and asks you express 4g of x minus not f of x plus 1 as a polynomial in standard form. Okay, so I'm going to write it exactly as I see. I write 4, I see g of x, I replace it by 2x minus 1. Minus, I open a bracket. It tells me f of x plus 1. What is that? It means that every time I see the letter or the variable x, I take it out and replace it by x plus 1. I have 5, x plus 1. Square, plus 3, x plus 1. Minus 12, well, there is no x, so it's minus 12. So I'm going to, let's say I'm going to distribute the 4 and expand this, and then distribute the 5 and the 3. So this is 8x minus 4 minus 5 times x plus 1 square is x squared plus twice x times 1 plus 1 squared. And then I can distribute the x, so 3x plus 3 minus 12. I distributed that. Now I have to distribute those. I leave everything else the same. 8x minus 4 minus, and now I can use parentheses, 5x squared plus 10x plus 5 plus 3x plus 3 minus 12. Next, I'm going to distribute the negative or the negative 1. So I get minus 5x squared, meaning when you have a negative, all what you have to do is to look at the signs and change them. Like this is 5, you make it negative 5. 10 plus 10, you make it minus 10. Plus 5 minus 5. Plus 3x minus 3x. Plus 3 minus 3. Negative 12, positive 12. Next, you combine like terms. The negative 5x squared doesn't have anything. It's the only square term. So I write negative 5x squared. How about the x? I have 8x minus 10x is negative 2x minus 3x is negative 5x. And then for the constant term, negative 4 minus 5 is negative 9, minus 3 is negative 12, plus 12 is 0. So that is the answer. Again, it didn't take like 3 minutes. With explanation, it shouldn't take you long at all. Okay, it's very simple algebra. Just substituting x plus 1 for x, distributing the coefficients, combining like terms, and that's it. Nothing hard. And that concludes the part 3 of the test. Part 4 is only one problem, usually. Yeah, it is one problem worth 6 credits. Okay. Everything in pen except the graph, of course, would be done in pencil. The height in feet of the tides along the coastlines can be measured with water level oscillating between low tide and high tide. The graph below shows the height of the tides, y equals b of t, in feet in Daytona Beach, t hours after midnight on a day in July. Okay, so that's the explanation of the problem. This is the graph of the tide. So low tide at midnight, high tide at 6 a.m., low tide at 12 p.m., high at 6 p.m., and 0 again at midnight. Okay, so that's a full day. Okay, now the first part of the question says, state the period of b of t in hours. When you get the period, you get two identical points on two consecutive sine waves or cosine waves. For example, I say it was 0 at time 0, it went to maximum, returned back to 0 at 12. So that's 12 hours. Someone else would say, no, I'm going to pick the max. The max 5 was at time 6. It returned back at time 18. Again, 18 minus 6 is 12 hours. So you can say first minimum, for example, was at t equals 0. Second minimum, for example, was at t equals 12. So period equals 12 minus 0 equals 12 hours. Or first maximum was at 6, second maximum at 18, and 18 minus 6 is 12. So the period has to be constant. Write an equation of bt in the form bt equals a cosine bt plus c. So I have to find 3 things. I have to find which t I'm going to use, what is a, meaning the amplitude, and what is c, where is my center line? Well, the center line is easy because if it's 0 is the minimum and 5 is the maximum, then the center line, so c equals max plus min over 2 equals 5 plus 0 over 2 equals 2.5. So I know C. Now, how about A and the cosine? This is a cosine wave. It starts at the minimum. And we know that the cosine starts 1 when t is 0, if I draw cosine t, but here it starts at -1. So all what you have to do is to say, since this is the center line, then A is -2.5, right? Because if it's positive, I would have started here. So A is -2.5. It's an inverted cosine, so it's like you are reflecting it over the x-axis. And the center line is in the middle. So this is a reflected one. I know the period. So in order to find B, we say B equals what? Equals the original period of a regular cosine, which is 2 pi for the sine or the cosine. And then you divide that by the period of that particular one. So I say 2 pi over 12 or pi over 6. So now my equation becomes B of t equals -2.5 cosine pi over 6t plus 2.5. And you can check. You can say, okay, if t is 0, cosine 0 is 1 times -2.5 is -2.5 plus 2.5 is 0. Let's look at the center line. The center line is at 3. So if I say t equals 3, 3 over 6 is 1/2, pi over 2. Cosine pi over 2 is 0, so you don't get anything from this, so you get 2.5, which is, yes, in the middle, it would be the center line is at 2.5. If you say t equals pi, t equals 6, which is the maximum. 6 over 6 is 1, so you get cosine pi. Cosine pi is -1 times -2.5 is +2.5 plus 2.5, you get the 5. So it's very simple, really, when you think about it. All righty, so the last part, or the last two parts. In Derby, Australia, the height of the tide in feet can be modeled by the function d of t for Derby. They didn't use Daytona as d again because both starts with d, so that there it's b, here it's d. 8 cosine pi over 6 t plus 16.5. Draw it on the grid provided here. Okay, so as we can see, even if you compare these two, it's both of them are cosine pi over 6t. One of them is 2.5, right? And one of them is 16.5. And that gives you the center line. So the center line is at 16.5. They want it in pencil. Okay. So here is 16.5. So this is the center line. We can draw it as dash line, just for simplicity, for clarification. I mean, you don't need to draw it, but center line. They give me the amplitude as 8. So if I add 8, I get the maximum, subtract 8, I get the minimum. So maximum is 8 plus 16.5 equals 24.5. And that these were in feet, right? Feet. And minimum equals 16.5 minus 8 equals 8.5 feet. And it's positive. So I start at the max. Why? Because the maximum you get when t is 0, cosine 0 is 1, and 1 times 8 is 8. 8 plus 16.5 is 24.5. So I start here. The period is still 12. So 3 hours later, They want you to draw from 0 to 24 again. At 0, so this is the 3, this is the 9, this is the 15, and this is the 21. That's where you go to the center line every time. So I start at 24 and a half. 3 hours later, I would be on the center line. 3 hours later, I will be at the minimum, not the maximum, because this was negative 2.5 cosine, and this is positive 8 cosine. So instead, this goes up 2.5, this goes down 8. So after 6 hours, you go to 8.5, which is here. And then at 9, you go back to the 0. At 12, you go back to the maximum. At 15, back to the 0. At 18, back to the future. Back to the minimum. Horrible, I know. 20, just to break the ice, you have a test coming, so just cheer up. And you get someone other than me to draw it because I'm horrible at drawing. But you will get something that looks like that. Oops. And we're done with the drawing. Here you can write 24 and a half. Here you can write 8.5. And here it's 16.5, the center line. And also, if you want, you can say d of t equals 8 cos pi over 6t plus 16 and a half. Just to show the equation that even though you already have it written. And finally, state the height in feet on the low tide in Derby. The low tide in Derby equals the minimum point, we already wrote it here, 16 and a half minus 8 equals 8.5 feet, or just a dash for feet. And that concludes your test, which I hope you learn how to do. If you have any questions, again, I would be around anytime. I check the comments at least twice a day. So, and I will get back to you as soon as I can. Otherwise, I wish you all the best in your exams. And I have to think of another exam. Maybe I'll do it geometry or trig or something in the future. Okay. See you soon. Bye.